NutriLab. What is it about? Let's first have a look at the practical ways for nutrient management which are common. First of all, of course, there is the soil analysis. A soil analysis shows which nutrients are available for plant take-up. The dry leaf analysis, it shows which nutrients a plant has taken up since the formation of this leaf. And the plant press-up analysis shows which nutrients the plant is currently taking up. So this is the most up-to-date, the most recent look you can have at the nutritional status of a plant. But of course, every analysis technique has its place. They are complementary to each other. NutriLab, however, is about plant press-sap analysis. Currently, we cover 75 plant species with 315 optimum values. That means that many species are covered in several development stages with an optimum. The development stage is defined according to the BBCH monograph. This is a free monograph available in English, German, French, and Spanish, which exactly describes the different development stages of the different species. This is available for free in the internet or also from our side. From the nutrient side, we cover nitrate and in many cases also potassium. Down here you have a list of all the crops which are currently covered. We are strong in ornamental plants, in a lot of different vegetables, in potato, in cotton, and in field crops like the grains and corn. What do we have to observe? The plant sample must be pressed and analyzed as soon as possible after sampling, after picking the sample from the plant. Never leave samples laying around in the sun before analysis. If analysis cannot be done immediately, store the samples in a plastic bag inside a cool box. The measurement of the sample must be made within 1 or 2 minutes after the sap extraction, and the best time for sample collection is noon between 11 and 14 hours. But make sure to always collect the samples at the same time of the day. In case you are not sure which is the best plant organ to sample, we have divided the plants into 13 sampling groups, and there is a mouse over help function in our web app. Pepper, for instance, is in the group 1. There you need the petioles of the youngest fully developed leaves. Wheat, for instance, is in sample group number 2. In wheat and the other grains, you need whole plants. And what you use as sample organ is the stem base of the whole plant. How to take samples? Generally, always take samples from healthy and average plants. Dirty plants or plants with attaching fertilizer or pesticide residues should strictly be avoided. Then you need to collect about 30 to 100 samples per management unit. That of course depends a lot on the species, on the size and the sap content of the sampling organ. And the samples should be taken randomly distributed over the management unit about the surface of sampling. So in case this here is a management unit, this would be one management unit, here we would have the next management unit, and this would be the third management unit of this plot, and so on. So you take the samples randomly distributed over the field. It has very well proven to use a W-shaped pattern across the field and take samples every few meters. Avoid the headland and untypical spots of this field. To use the app, we have to go to the web app. This is nutrilab.mmm-tech.de. And we have to log in. The login name and the password would be provided when you first subscribe the service at us. The web app has the dashboard. At the moment we don't have a running project. We have the project section where we can create various projects. We have the archive. Here we have an old project from last year inside. I'm going to explain about this later. We have the advices side. Here we can see what optimum ranges for which crops in which development stage are there. We have here the crop name, the nutrient, and the BBCH development stage. So let's start by creating a new project. We will use the demo crop pepper. The plot name may be plot number 2. The crop is pepper, of course. And then we have to choose the reference crop, which crop we're going to use as reference. Since we have pepper in the database, we of course use pepper in this case. We have to define a start date. This was in May this year, May 3rd, and we save it. If we started with our transplants beginning of May, we will have a few weeks later the plants big enough to take samples, so we take our first samples on June 1st, and we have a BBCH stage of 51. 51 is the BBCH stage of flower emergence, beginning of flower formation. We measure 6,500 ppm nitrate and 3,300 ppm potassium. We save, and we can instantly check whether we are in the good range with these measurements. At the moment we don't have really a graph because we just have one measurement, but we see for nitrate we get a green tile here. This tells us, okay, we are in the optimum range because we measured 6,500 ppm. The optimum range would be at this stage 6,200 to 7,100 ppm. Same applies for potassium. We have measured 3,300 ppm. We also have for the potassium a green tile. The optimum range would be 3,200 to 3,500 ppm. After 10 days we take the next measurement. We have reached BBCH stage 53 then. We measure 5,800 ppm nitrate and 2,900 ppm potassium. We save it, we control it, and we see for both nutrients we are a little bit under the optimum range, therefore the tile is red. We see we have 5,800, we should have at least 6,200 ppm. Similar with the potassium, we have measured 2,900 ppm, we should have at least 3,200 ppm. Therefore we know that we have to increase the fertigation a little bit, which we do, and 1 week later we make the first control measurement. This is now on the 17th of June. We have reached the BBCH 55 and we have a measurement. We increased our fertigation and we measure 6,300 ppm for nitrate and 3,250 for potassium. We save it, we control it. And see, due to our increased fertigation, we are back in the optimum range. We are still at the lower end, as we can see here. We are just 100 ppm over the minimum for this growth stage, but nevertheless we see an effect of our increased fertigation. Same applies to the potassium. Here we are also on the lower end, and this tells us that we still can give a little bit better nutrition to our crop, which we do. So after another 10 days, we control again the effect of our increased fertigation. This is now done on June 28th. We have reached the BBCH stage 61 then. We measure in this stage nitrate content of 6,500 and a potassium content of 3,400. We save it and we control it. Okay, we see an effect. We are in the middle of the optimum range for the nitrate, but for the potassium we overdid it a little bit, since we are now over the optimum range. This means we have to reduce our potassium applications a little bit, which we do as consequence of this last measurement, and control this again about 10 days later. So now this next measurement would be on the 8th of July. We are in the BBCH stage now of 64. And we measure nitrate content of again 6,500, and we reduced a little bit the potassium fertigation, so now we reach 3,100. We save it, we control it, and now with the nitrate we are still in the optimum range, while with the potassium, as we can see here also on the green tile, we are back in the optimum range, so we see an effect of our used potassium fertigation. And we will continue to do this over the whole growth cycle, the growth period of the crop, and therefore we can monitor how well we do with our nutrient applications almost live, almost at the same time as we do it, and it's a quick access to have a good overview on the nutrient content and the crop nutrition inside the plant. Then, since we have the archive function, we can also compare this with older projects. We have here our pepper cultivation from 2021. Let's just see how this was. In this year we had just had 4 measurements, which all have been in the optimum range. For nitrate and also for potassium, we never lost the optimum range, so last year we did a little bit better with our fertigation compared to this year.